Hi guys, we are continuing with our lead coding and let's check our next task. So our next task called check completeness of binary tree. So we are given a root of binary tree and we have to determine if it is a completed binary tree. In complete binary tree, every level except possibly the last is completely filled. And all nodes in the last level are as far left as possible. It can be between 1 and second nodes inclusive at the last level H. So we have 1, 2, 3, and here we have like 4, 5, and 6. So we have every level before the last is full. So levels with nodes 1 and 2, 3, and all nodes in the last level 4, 5, 6 are as far left as possible. Okay, and here we see like 1, 2, 3 is complete, but here the last nodes are not full, so we have like null at the last level. Okay, so I think that what we can do, we can do as following. We can do BFS over each level and collect every element. And if some node has empty value, we just store -1 as a null node. And this one we will check level by level and will return Boolean in case of some level has incomplete. Okay, so solution is actually BFS, so time complexity would be linear, and space complexity would be also linear because in BFS we use Q. All right, so we need a Q with 3 nodes, and we see from constraints that we have at least one. So we have our Q. Linked list. We add to our queue our root, and here while our queue is not empty, we are doing the following. We should we should have children's, sorry, to the area list, and here we also have our value. So we have integer values. Okay. And here, while Q is empty, while it's not empty, what we are doing, we pull from the Q 3 node, and here we pull from the queue, then we add to our values. We add our node val, and Mm-hmm. Here is empty. Yeah, we need to check if yeah, we have level, each level. So let me think. So we have like a level that would start with 1, and then each iteration, this level should be increased by 2. But what this level will give us? So for example, I'm on the first iteration, I add 2 values 1, and I check that, okay, okay, so I think that this one is actually would be the last one when I don't have any children. So let's do the following. So I add this one to my values, and then if if node left null not null, I add to children node left, and here node right. Node right. Okay. So when our children's is size equal to null, that means I have my last level, and when I have my last level, I need to have also my values. So I add this one, so when I'm on the second one, so for example, let's imagine that I'm on the first one, I take 1 and I put 2 and 3. And I should check that I have this one. Then I have 2 and 3. So when I pop 2, I put 2 and put 4 and 5. Then I pop 3 and I put Yeah, so each level, but here I should check values actually. So when I'm on the last level, yeah, maybe I need this level. So I need level multiplied by 2. Else if values size not equal to level, I will return false. And here, if it's my last one, I have 4, 5, and 7. But I don't know if it's left or right. But I don't know if it's left or right. Yeah, and here it's the most interesting how it can be done. Okay, when I'm on the first, I add 2 and 3. Okay, when I'm here, I get 2, I add 4 and 5. Then maybe in levels, I should get values. Okay, when I'm 4, would be 4, 5, 7. When I'm on last level, it will be 4, 5, and 7. 2, 3. Okay, so I think it doesn't matter whether it's the last level or not. Actually, I need to feel, yeah. Yeah, I need to do the following. I need to add into my values right over here, else I'm adding values and -1, else values and -1. And -1 actually is possible if it's not the last one. But how can I determine if it's actually the last one? How can I determine if it's the last one? Okay, so this value is actually the current one. Maybe pref values, let's say. Values the current one. And next. Okay, so I have one. Okay, one. And I have some children's. Okay, so I don't need to check it. Then I have 2 and 3. Yeah, current values, actually I need this. But what if I have this one? 4, 5, and 7. And like current, I should have current and also previous, like what previous added, right? Like for 1, I have null. For 2 and 3, for 2 and 3, I should have for 4. Yeah, I should have 2 and 3. And for 5 and 7, I should have, yeah, how it looks like. Okay, so let's call this pref. And this actually pref, how it works, we add into the pref node left value, and here right value. Otherwise, we add pref add -1, -1, and here we are doing the following. So in the last, we should check that all have values. With -1. How to do this? How to do this? So we have values, and if we see first -1, okay, so let's see, like we have boolean that is empty will be false, and we iterate through our array. So our pref, and if value is equal to -1, we make empty equals true, and if empty equals true and value not equals -1, we return false. Okay. And here at the end of these things, we should return true. But before this, we should also iterate through our children's 3-node children and make like you add children. Okay, let's run it. Empty equal true. Okay, so if it's true and value not equal -1, well, okay. All right, so we have output true, but expected false. Let's figure out why. Okay, so let's imagine that we have 1, right? So our queue is not empty. We pull 1, we take values 1, and to prev we add 2 and 3. Here we are not going here because we have our children's. So we check, okay, values size. Yeah, not equal level, so it's equal level. It's 1. And yeah, and we implement our level and add to the queue all children's 2 and 3. Then we iterate. Here we have 2. We put into our values 2. We check for 2. We have 4 and 5. So we add 4 first. And also we add to our prev 4 and then 5. I think there's a problem here. Then I like take 3, right? I add 3. And here I add -1, 7. And then I check, it's not last one, because it's 4, 5, and 7. And actually I return from here and then I update my prev. Maybe what I can do, I can have like a map of level and a list of values. Map, new hash map. And what I can do, so I'm adding this prev, and then what I do, I can do the following. I can do like like this one. Map put level and brief. And here I take this one like map get level. Okay, let's submit it. Null pointer. Okay, so when I have only one element in my root, okay, I have only one element, children 0. Yeah, so I think it's here. So maybe if our root left equal null and root right equal null, so it would be our edge case. I return, what should I return? True. Okay, nice. So we are done with this question. Yeah, it was quite interesting. Let's check what do we have here. Okay, we have Boolean, we queue add root, while queue is not empty, we pull element from the queue, we check if current is null and true, else if and false, queue left, right. If current equal to null, we end true. Okay. So if current is not equal to null, for example, and is false, so we add left and right, then we have, for example, left, and here we add null and null. Then we pull the queue, it's null. So and is true. Then we again pull from the queue, it's null. Okay, not really, how to say, understandable. But I think my is a very complex one. So here, okay, so we have our queue with 3 nodes. We put a root while PQ quiz node. So we pick and queue offer left and right, while any remaining null. Okay, BFS with root, track leftmost high. Okay, so we target height. So what will be our height? If R is equal to null, and if target height equal to null, then target height equal to h. Okay. Yeah, with DFS it's quite a complex one. Okay, so I think that's all. Thank you.